So our next topic is characteristic, Mantissa and antilog. So let us try to look at what characteristic and Mantissa of a logarithm is. So first, we know that log 10 is equal to 1, taking the default base as 10, and log 100 is nothing but 2, right? Because the base is 10. So if you want log 100 to the base 10, you need to ask what the power of 10 is that brings you 100. So 10 square is 100, and log 10 cube to the base 10, that is log 1000 to the base 10, is equal to 3, and so on. Now if I ask you a question, what is logarithm of 25? So as you can see, 25 lies between 10 and 100, right? So 25 lies between 10 and 100. So log 25 lies between log 10 and log 100, right? So log 25 lies between log 10 and log 100. And what is log 10? It's 1, and log 100 is 2. It is log 25 lies between 1 and 2. So log 25 will be of the form 1 point, there will be some decimals, let us say A, B, C, so on. 1 point A, B, C, so on. Now you have an integral part of this number and a decimal part of this number. So this can be written as 1 plus 0 point A, B, C, so on. 0 point A, B, C, so on. So this part is called the characteristic part, and the decimal part is called the Mantissa part. So whenever you calculate log of any number, if you get something, point something else, the integer part of the number is called the characteristic, and the decimal part of the number is called Mantissa. For example, log 2 to the base 10 is equal to 0.3010, so on. These are the first 4 digits. So this implies the characteristic of log 2 to the base 10, the characteristic is 0 and the Mantissa is 0.3010. It's as simple as that. So whenever you calculate the characteristic of some number, some log, you just need to find the logarithm. So whatever is the number before the decimal point, that is the characteristic. Whatever is the number after the decimal part, it is the Mantissa. And one of the important things that you need to remember is that Mantissa of a logarithm is always positive. Always positive. And if you take some log x, if the characteristic of this log is c and the Mantissa of this log is m, then c plus m should give you the value of log x. So now, if log x, if logarithm of some number is equal to 2.313, if logarithm of some number is 2.313, the characteristic of this logarithm will be equal to 2, that is the number before the decimal point, and the Mantissa will be equal to 0.313. If the value of logarithm is positive, the understanding is quite simple. So now let us go to a special case where the value of logarithm is negative. We have seen that the values of logarithms can be positive or negative. So let us say that log x is equal to minus 1.4. Minus 1.4. So what is the characteristic of it? So if I write the characteristic as minus 1 and the Mantissa as 0.4, it leads to contradiction. This is wrong, because if characteristic is minus 1 and Mantissa is 0.4, what should be the value of log? Minus 1 plus 0.4, which is equal to minus 0.6. So if log x is minus 0.6, then the characteristic will be minus 1 and Mantissa will be 0.4. So if log is minus 1.4, so what we do is the characteristic of this is 1 less than minus 1, that is the characteristic is minus 2, and Mantissa is written as the complement of 0.4, that is 1 minus 0.4, which is 0.6. So the characteristic of minus 1.4 is minus 2 and the Mantissa is 0.6. Similarly, if log x is equal to minus 2.35, the characteristic of this logarithm will be minus 3, not minus 2. And the Mantissa will be equal to the complement of 0.35, that is 1 minus 0.35, which is 0.65. Such that once you add these two, you get the value minus 2.35. So these are the two things that you need to remember about the characteristic and Mantissa. First is Mantissa is always positive, and the value of logarithm of any number has to be same as the characteristic plus Mantissa of that logarithm. So next, where does characteristic of a logarithm becomes important? So in which type of problem that does characteristic become important? So one of the most important type of problem that you can solve is the number of digits. So if you want to find the number of digits in some very large number, if I say 2 power 56. So if you raise 2 to the power 56, it gives you a very large number. And if I ask you how many digits are there in 2 power 56? So this is one of the questions which you can solve using the concept of characteristic of a logarithm. And the next question is the number of zeros. The number of zeros after the decimal point, in 1 by 2 power 65. So if you take 1 by 2 power 65, it's a very, very small number, 0.00000, have a lot of zeros, and then finally you have some number. So if I ask you how many zeros are there just after the decimal point before the non-zero number starts. So these are two types of problems where the characteristic becomes important. So let us try to analyze how characteristic becomes important in these type of problems. So if I take log of 25 to the base 10, if I find log of any number to the base 10. So this can be written as log of, so this number can always be written in the form of something like this, 2.5 into 10 power 1 to the base 10. So I can always make this number in between 1 and 10. So I can always bring this number between 1 and 10 and write an appropriate power of 10 after that. For example, if you have 256, I can always write it as 2.56 into 10 square. If I have 0.25, I can write as 2.5 into 10 power minus 1. So I can always use appropriate powers of 10 and bring this number between 1 and 10. And what I do is now I'll separate it using the properties of logarithms. 2.5 to the base 10 plus log 10 to the base 10. And if this number is in between 1 and 10, if some number is in between 1 and 10, log of that number will be in between log 1, 0 and log 10, 1. That means if x is in between 1 and 10, log x is in between 0 and 1. That is, this has to be of the form 0 point something. So this number will always be of the form 0 point some number plus log 10 to the base 10 is 1. So the characteristic will be this power of 10 whatever you get plus, and whatever number you get here will be the Mantissa of the logarithm. So as you can very clearly see, the power of 10 that you get here will be the characteristic, and the number that you get here, log 2.5 to the base 10, will be a decimal, and that will be the Mantissa of that number. Now, How is this characteristic related to the number of digits? If 25 has 2 digits, the characteristic will be equal to 1. So let us take log 256. So if the number has 3 digits, so this can be written as log 2.56 plus log 100. Log 100 is nothing but 2. So this will be 2 point something. So if there are 3 digits, the value of logarithm will be 2 point something. That is, the characteristic will be 2. If the number is 2566, so log 2566. So this can be written as log 2.566 into 10 cubed. So this will be 3 point something. So can you see the pattern here? If there are 2 digits, then the characteristic of the logarithm will be equal to 1. If there are 3 digits, then the characteristic is equal to 2. If there are 4 digits, the characteristic is equal to 3. If you want the number of digits in any number, so the number of digits in x, so number of digits in a number x is nothing but the characteristic of log x to the base 10 plus 1. So this is the formula for number of digits in any number. So if you have a very big number, so if you want the number of digits, so what you just need to do is you just need to calculate the log of this. You find the characteristic and add 1 to that. So next, let us try to see the pattern for the number of zeros immediately succeeding the decimal point. So let us take an example. What is log 0.5 to the base 10? This can be written as log of 5 into 10 power minus 1 to the base 10. That is equal to log 5 to the base 10 plus log 10 power minus 1 is nothing but minus 1. Hence the characteristic will be equal to minus 1 and the mantissa will be equal to log 5 to the base 10. So similarly for this, the characteristic will be equal to minus 2 and the mantissa will be equal to log 5 to the base 10. And similarly in this case, minus 3 plus log 5 to the base 10. Now as you can very clearly see, if there is no 0 just after the decimal point, you get characteristic as minus 1. So if you have 1 0, the characteristic is minus 2. If you have 2 zeros, the characteristic is minus 3. So if you want the number of the zeros immediately after the decimal point, you just need to find the characteristic of this and take the modulus of characteristic. That is the absolute value. You just remove the sign. So whatever you get is the mod of characteristic, and if you subtract 1 from that, you get the number of zeros. So the number of zeros in 0.005 immediately after the decimal point is nothing but modulus of minus 3, which is 3 minus 1. Modulus of minus 2 minus 1, that is 2 minus 1, 3 minus 1, so on. So mod c minus 1 is the number of zeros immediately after the decimal point. So these are the two formulas. The number of digits in any number. Number of digits in any number is nothing but the characteristic of that number plus 1. And the number of zeros immediately after the decimal point of any small number is nothing but mod of characteristic minus 1. So these are the two formulas which you need to remember. So let us take an example. So in a given question, you're given that log 2 to the base 10 is 0.3010. This information is given to you. Using this information, can you calculate the number of digits in 2 power 56? Let's take the same example. So if you want to solve this question, what you need to do is, if I want the number of digits in a number x, I need to calculate log x. So first we'll calculate log 2 power 56 to the base 10. This is nothing but 56 times this power goes outside. 56 times log 2 to the base 10 is 0.3010. 56 times 0.3010. So that is nothing but you just need to multiply these two. 0.3010 times 56, 0, 6, 0, 18, 0, 5, 0, 15. So 16.856. So the value of this logarithm is 16.856. So what is the characteristic of this? The characteristic is nothing but 16. So the number of digits is nothing but, by the formula, the characteristic plus 1. That is 16 plus 1 is 17. So the number of digits in 2 power 56 will be 17 digits. So looks simple, right? Now let's go to the next question. I want the number of zeros immediately succeeding the decimal point in 1 by 2 power 63. So to find that, first let us find the value of this logarithm. So log of 1 by 2 power 63 is nothing but 2 power minus 63 to the base 10. That is minus 63 times log 2 to the base 10 is 0.3010. Right? So 63 into 3 is 189. So this will be something like minus 18.9. So this will be minus 18.9. I'll just calculate this nicely. So 63, so 0309, 06018, so 036981, so 18.9630. So the value of logarithm is minus 18.9630. So what is the characteristic of this? The characteristic, because this is a negative number we have already seen, it will be 1 unit backwards. The characteristic is minus 90. The characteristic is minus 90. So the number of zeros immediately after the decimal point is nothing but mod c minus 1, right? Mod c minus 1. That is nothing but modulus of c is 90 minus 1 is equal to 80. So in another way, this is nothing but whatever number you get here, that will be the number of zeros immediately after the decimal point. So you can remember it as you want. So you can calculate the characteristic by taking the number before this number and then subtract 1 from that after taking the modulus, or you can directly report this number as the number of zeros.